Hello everyone, hope you are doing well. I'm Reza, founder of the optimizationcity.com. In this field, we are talking about the Dijkstra Algorithm for loop network and solve an example of this problem. Let's move on.
In the loop network, there are arcs that create loops, allowing the movement between nodes in both forward and backward direction. To find the shortest path in such network, two methods are commonly used. The first method is the Dijkstra method. This method is named after its inventor. In the Dijkstra methods, two codes are assigned to each node. The first is the M sub I. This represents the shortest distance of node I from the origin up to the current step of the algorithm. It is known as a temporary code since the shortest path may be updated in a subsequent step. M capital sub I. This represents the shortest distance of node I from the origin and is referred as a permanent code. Once assigned, this code will not be updated with the shortest distance in the following step. The Dijkstra method can be summarized in the following step. Step 1. Start by assigning the permanent code of 0 to starting node. M1 is equal to 0 because node 1 is a starting node. Assign the temporary code to the node adjacent to the node that already have the permanent code using the following formula. Temporary code of node j, m sub j, is equal to minimum of the permanent code of node I plus dij. Here, dij represents the direct distance from node I with the permanent code to the adjacent node j with the temporary code. If a node already has a temporary code, it is compared with the new temporary code and the smaller value is chosen. Among the all node with the temporary code, the node with the smallest code is converted to a permanent code here. The process continues until by assigning the temporary codes to the node adjacent to the node with the newly assigned permanent code and so on. In step 3, we stop the algorithm when the end or destination node receives the permanent code. The value of the m sub n and the number of nodes represent the shortest distance between the end node and the starting node. In step 4, we find the shortest path. We use the backtracking method with the following relationship. Here, m sub I is equal to m sub j minus d sub ij. If this relation holds, arc ij is on the shortest path. To better understand this step, let's solve the following example. Here, this is the example, and the number over the arc is the cost. We are going to find the shortest path using the Dijkstra method from 1 to 7. Here the solution we find in the optimal shortest path between 1 to 7. We start by assigning the permanent code to node 1, where m sub I is equal to 0. Since node R has received the permanent code, we assign the temporary code to its adjacent node. So here, node 2, 4, and 3 are the adjacent node to node 1. So we assign the temporary code to these node. M2 is equal to 3, M3 equal to 7, M4 is equal to 5. Among the temporary code available so far, the 3 code, the minimum value is 3 for M2. Therefore, the temporary code of node 2 is converted to the permanent code. We assign the temporary code to the node adjacent to node 2. Node 2, we have two adjacent nodes, node 5 and node 4. Okay, node 4 already had a temporary code of 5 here. From the last step, we know that a node 4 is equal to 5, the permanent code of node 4. But here we find that the node 4, the temporal code of node 4 is equal to 4. So the minimum value of the 4 and 5 is equal to 4. Then we update the temporal code of node 4 to 4. And we find the minimum value of the temporary code available here. We have 3 temporary codes so far, 7, 4, and 13. 4 is the minimum value. As a result, node 4 received a permanent code with value of the 4. This process continues in this manner, assigning the temporary code and updating it accordingly. The diagram here summarizes the result of the different steps of the algorithm, and you can see that the node 4 has the permanent code and defining the shortest path. We find the shortest path from 1 to 7 with the value of the 11. Here we can see that the node 5, no permanent code for node 5. To find the shortest path between node 1 to 7, we can use the backtracking method. We follow the similar approach in the network without loop in the earlier slide. We start by examining the arc and node along the shortest path. Arc 5, 7 is not on the shortest path because M5 is not equal to 5. There is no M5 because we do not have the permanent code for node 5. As a result, arc 5, 7 is not on the shortest path. But arc 7, 6, 6, 7 is on the shortest path because M6 is equal to 8. No, arc 4, 6 is on the shortest path because M4 is equal to 4. Arc 3, 6 is on the shortest path because M3 is equal to 5 and so forth. Here you can see that the arc 1, 3 is not on the shortest path because M1 is not equal to minus 2, is equal to 0. Here arc 1, 2 is on the shortest path and also arc 2, 4 is on the shortest path. As a result, we have the two shortest paths here from 1 to 7. And in this figure, you can find the shortest path. The one shortest path is 1, 2, 4, 6, and 7, and the other is 1, 2, 4, 3, 6, and 7. All both shortest path has a value of the 11. Thank you so much for watching me. If you are any question and need any assistance, please do not hesitate to contact us by email or by filling the contact form in our website, which is www.optimizationcity.com. Thank you so much and goodbye for now.